Hi guys, and welcome to grade 11. It's physical science and it's going to be a rocking show. As you can see, I've got Bruce next to me. Hi Bruce.
Well, and thanks, you, Indy.
Good. I'm excited to be doing a show with you.
Excellent. It's been a long time, eh?
Yeah, and today we've got an exciting lesson. It's all about gold. It's about the bling bling and the gold.
Yeah, Indy said we're going to have a rocking time. Well, we're going to be looking at gold mining and
Exactly.
obviously extraction of gold from the rocks and its applications in South Africa as a gold mining country. And I'm going to be taking you through some of the important aspects of gold and gold mining and its extraction in the next hour.
Awesome. Okay, Bruce, take your spot
Great.
while I do my usual thing. Okay, guys, what you need to do is you need to chat to us on facebook.com/learnextra. Also chat to us on Twitter @learnextra. I'm here to help you out with anything you may need. If there's anything Bruce is going over, pop it on the page and I'll get him to answer as we're going along. We want this to be an interactive lesson. And don't forget that this page is not just for us guys, it is also for you. So start chatting. Before we start, it's the usual. We are giving away a Casio calculator today to the person or the learner or the mindsetter that posts the best post, whether it be an inspirational tip. You might be helping out another mindsetter. Maybe it's a quote, even a question. Let's just get chatting, guys. Also, big shout out to Liberty. You guys rock. Thanks so much for making this show possible. And before we run out of time, let's go over to Bruce. Bruce, take it away.
Great, Indy. Thanks very much indeed. Guys, as we said in the introduction, what we're going to be doing is having a look at the gold mining industry in the country. Now, you might say, well, how scientific is that? Well, it's not really got too much to do with the physics and chemistry that you guys are probably used to. However, it certainly does apply to the science of geology and probably geography. Okay, so there might be you might find, shall I rather say, quite a big tie-in between your geography, those of you guys who do geography at school, and what I'm going to speak about today. I'm going to run through a couple of important aspects associated with the Earth and the Earth's crust, and then we're going to look at the gold mining industry per se. We are going to look at the extraction of gold. There is a little bit of chemistry associated with that, and then we're going to have a look at a typical type of question that you might come across in an exam. And probably to end the show today, I'm going to be looking at the environmental impacts of gold mining in South Africa. And a lot of you guys will probably have a few thoughts and a few ideas, and maybe you want to drop them onto the Facebook. Your ideas about the environmental impacts of gold mining in the country, and maybe just in mining in general, because it can be such a controversial topic, not only in South Africa, but also internationally as well. So guys, what I've done, I've just developed an introductory slide here where we're going to have a very basic look at the chemistry of the Earth's crust. Now, if you watched last week, I think Tracy took the lesson on this, and she probably would have introduced some of this to you already. If she has, that's great. It'll be revision. If she didn't, well, this is just a couple of little pointers to get us through and to sort of set up the lesson on gold. And the important thing is that the Earth's crust is made up of approximately 80 different elements. Okay, and those 80 different elements can combine into over 2,000 compounds. Okay. Now, what are our most common elements that we've got? Well, the most common elements that we find are going to be oxygen, silicon, aluminium, iron, and calcium. Generally, they make quite a bit of the composition of the Earth's crust. Okay, iron, you probably know, you've probably heard a lot of iron-based compounds. Aluminium, you're probably not too sure about, but aluminium actually is one of the third most abundant elements that we actually have in the Earth's crust. Okay, so very important that we are able to speak about aluminium, and in fact, when you get to grade 12 next year, when you do your electrochemistry section, there's a whole section on the extraction of aluminium and how we extract aluminium from its mineral, from its ore, and you learn about that next year as one of the electrochemical processes. Okay, however, let's have a look now at a few things that are important, a couple of important little terms that might be that you guys need. It says these metals are seldom found in their pure form, so it's very rare that we actually find pure aluminium. Very rare that we find very rare that we actually find pure copper. It's very rare that we actually find pure iron. We always find it mixed and bond, or shall I rather say, in a sort of chemical compound, and that chemical compound is what we mine, and then we actually purify and extract it out of the ore itself, and we are able then to get to isolate the compound. But we often found them in the substance, what we call a mineral, okay? And it's quite important to understand what we mean by a mineral. Now, there are quite a few definitions of minerals that that you'll probably see in textbooks. And yeah, look, there's a lot of discussion that goes on as to what is actually the correct definition of a mineral. I know in some of the textbooks out there, I personally don't agree with the exact definition of a mineral. So what I've done, I've taken sort of extracts, or I've sort of amalgamated and joined together a whole lot of facts from the textbooks, and I've produced a little understanding of what I think of basically as a mineral. Minerals are naturally occurring compounds that are found in the Earth's crust, which describe the chemical composition and structure of that substance. Okay, and that's quite enough. I think that sort of encompasses pretty much everything that we would probably need in a definition of what an actual mineral is. It's naturally occurring, okay, in the Earth's surface, and it describes the chemical composition and the structure of that compound that's present. Now, I've got some examples here of some minerals, and you'll see that some of them are actually quite complicated in their chemical formula. Now, guys, you don't have to worry about having to learn this, okay? I'm just putting this up here for a little bit of interest and information. A mineral that's probably everyone's heard about is quartz, okay? That's basically silicon dioxide. Now, that's a fairly simple sort of formula that we've got there. Now, gold itself is also classified as a mineral. And you might say, well, isn't gold a pure element? It's not actually found in a sort of chemical compound. Well, gold can be classified as a mineral because it is naturally occurring in the Earth's surface, in the Earth's crust. Gold is actually a particularly unreactive substance. So therefore, they can mine gold, okay, in its pure form. However, there is a type of compound called calaverite, okay, and calaverite, and calaverite is a mineral that involves gold and tellurium, okay. Now, tellurium is a very exotic element. It's found as one of the very heavy metals in your periodic table. The chemical formula for tellurium is Te, and you probably find you might have not even come across it before. Okay, so it can get quite complicated. Hematite, I think a lot of people might have heard about hematite. Okay, it's an iron oxide, Fe2O3, fairly simple formula. Everyone's heard of iron oxide, but we actually call that hematite, and the iron oxide is one of the components of rust. It's sort of that reddy brown color, but we do find it in the Earth's crust as hematite, and we do mine it as iron, and we will be doing a program on iron and the extraction of iron ore from the Earth's crust a little bit later on, the next couple of weeks. So guys, you can certainly tune in and make sure that we understand that. And then we get a substance called orthoclase. Now we're getting to some quite exotic looking substances. Well, if you have a look at that chemical formula for orthoclase, well, look at it. Potassium, aluminium, silicon, and oxide. Now, you're probably saying, wow, where on earth do they get a chemical compound like that? Very, very fancy chemical compound. Guys, you certainly will not be asked to give the chemical structure for that. All I'm trying to show to you guys is that these minerals that we do find in the Earth's crust can be quite complex. Okay, and obviously then we need to extract. Okay, the fancy name, potassium aluminium silicate. And then we have copper. Okay, now copper we find as a substance called malachite. Okay, malachite over here, which involves a copper carbonate hydroxide compound. Okay, also quite exotic, although we can find copper in its pure form, and we are able to extract it in its pure form along that way. So guys, there now is just a very brief overview of some of the minerals, defining a mineral, what is a mineral, and just some of the more exotic ones that we do get. But what we need to do, obviously, now is we're going to focus in on gold. Okay, we're going to look at gold because it's one of the major minerals that we do mine in South Africa. It is very important in terms of our economy, okay, because of the amount of money that gold can generate for the country in terms of being able to sell the gold to the rest of the world. And if you watch TV, I think you can see the gold price is around about $1,700 an ounce, which is rather a large amount of money, so therefore highly profitable to actually be able to extract this gold out of the earth and be able to sell it on. And South Africa is one of the major gold-producing countries of the world. So it's really, a lot of the gold is concentrated at the southern tip of Africa, good for us, and we can sell it on to the rest of the world. Okay, right, now, let's have a look now at the mining and processing of gold. Right, bit of history. When was gold discovered, guys? Well, gold was basically discovered on the Witwatersrand, a farm called Witwatersrand, and it was in 1887 that there was this sudden rush. They found gold on the Witwatersrand, and all of a sudden, all these people came, and there was a gold rush in South Africa. If you know a little bit of history and you watch maybe some other television, there are other places around the world that have had gold rushes. I know there were lots of gold rushes in California in around about the 1840s, in Alaska, okay, in Australia. But in 1887, the eyes of the world turned on South Africa. They found gold, and people came flocking from all over the world to South Africa, landed by ship in Cape Town or Durban, and then made their way up to the Witwatersrand, and from there sprang the village, which then was expanded out, and in a very short time became this huge city, which we now know as Johannesburg. And we also know that the native South Africans named Johannesburg Egoli. Egoli simply meaning the city of gold, and that's where Joburg got its nickname as such. Right, now, how was gold actually extracted? Now, guys, this is reasonably important because they can ask you questions on this in your exams, and there are three main techniques. I'll put you a number of techniques we use, but I'm going to concentrate only on three main techniques. The first one is the simplest technique, and this was probably used by the early miners when they got to the Witwatersrand. They were finding gold on the surface, and therefore they were able to basically pan for gold. Now, a lot of the gold is found in streams because generally it's washed through by water. So what the first miners would have done is basically, well, let's call them surface miners because they were on the surface of the ground. They were basically going to the streams and panning for gold. Okay, and how does panning for gold take place? Well, it's very simple. I've got a little picture there for you guys. Well, we have a pan, which is called, it's just basically a sifting pan, and what they do is they put sand and they put gravel and they mix it with water and then they shake it. Okay, and the important thing is that gold is a very heavy, very dense material. Therefore, pure gold would actually fall to the bottom of the pan. The sand and the gravel would basically sift out of the pan or move out of the pan, leaving the small little flakes, chips, nuggets, whatever, if they were really lucky, got a nice nuggets of gold behind, and the prospector, as that's what they called them, the guys who were panning for gold, the prospector would then be able to take the gold, and he would then go and sell it. And they would have a sort of a measuring scale, and they were able to sell their gold, and that's how they made their money. Now, the other areas in South Africa around about the same time, Pilgrim's Rest was a very, very popular area. They found gold in Pilgrim's Rest. And another place in the Mpumalanga region was a little village called Barberton. And you might remember that name, Barberton, along the way. That's where they also found gold. So, yes, they had found deposits of gold around South Africa, but on the Witwatersrand, that's where the big strike was in 1887. Right, now, as we start getting more and more gold being found, and they were now obviously starting to discover the gold on the surface. Where was the gold? Well, obviously on the surface was fine, they could pan for it. But if it was fairly close to the surface and they had to go down a bit, another technique that they're able to use to extract gold is what is called open cast mining. And there's the diagram there. And open cast mining is simply digging down layer by layer as they go through the gold-bearing rock. Okay, layer by layer, they were able now to extract or pull the gold out of that gold-bearing rock, and they were able to cart it off. Okay, obviously, more difficult type of work because it's not as simple as panning for gold. But if there is gold, they've got to dig down underneath the top surface of the soil, and therefore open cast mining was another example there. Now, we don't have much open cast mining in South Africa when it comes to gold. The reason being is that the gold-bearing rock that we have got in this country is actually pretty deep. Okay, it sort of goes down at an angle, a diagonal trajectory. So if we had to go open cast mining, we would have to have a huge area, which would have to be dug layer by layer, and that was just too labor intensive. So the third method of gold mining is what they call shaft mining. And that is probably 90% of the gold mining companies in South Africa use the technique of shaft mining. And that picture I'm sure you've seen quite a lot of, especially the learners who live in and around Johannesburg and maybe in the gold belt towards Vereeniging and down that way towards Velkom in the Free State. There we have our shaft mining. Well, guys, what we've got there is a very typical type of setup, and that now represents simply the lifts that go down the shafts and are able to drop the miners down very deep into the Earth's surface, and then what they do is they tunnel into the rock with their drills and things like that, and the miners are able to drill, blast, extract the ore, and then send it upwards. Okay, and there we now have the shaft mining technique. Okay, pretty dangerous type of technique, guys. Okay, unfortunately, lots of accidents do happen. We still have accidents in this country. As soon as you go deep under the Earth's surface, all possibilities of rock falls that come in, cave-ins, okay, explosions through pockets of methane gas and stuff that are trapped between the rocks, highly flammable gas, methane gas, and unfortunately, it does lead to a certain number of fatalities in the gold mining community. So it is quite a dangerous technique. Okay, and what I've done here is just to try and show you a little bit of a summary of all those techniques. So what we've got here, if these sort of dots, okay, and these layers represent the gold-bearing rock, in other words, where the gold deposits are, can you see now that where position number 1 represents quite a close gold seam near the surface? Okay, so near the surface, these portions of the gold-bearing rock, that could be easily obtained through open cast mining, no problems there. However, do you see now number 3, okay, can you see that this gold-bearing rock is now sloping downwards? So therefore, open cast mining is not going to work for that one. So what we're going to have to do is that we're going to have to sink a shaft, okay? So here's your shaft. Whoops, let's get a pen up and put it there. So we're going to put the shaft there. We're going to sink our shaft, okay? And as we sink the shaft down, then we can drill tunnels, okay? And there are the tunnels going into there. We drill the tunnels, following the rock. And as you can see now, there is the gold-bearing rock in these tunnels over here. And therefore, the miners are able to trace and follow that gold-bearing rock. And if it had to go deeper, okay, then what we do is very simply, they would drill more shafts into the earth like that, and they would then follow the gold all the way down. Guys, we start talking about some pretty serious depths here. We go down to nearly 3 kilometers, 4 kilometers underground. And if I'm not mistaken, I think South Africa holds the record for the deepest shaft mine in the world, where we've gone down almost 4.5 to 5 kilometers. Very, very difficult conditions that deep underground. Very, very hot, okay? Very dangerous conditions, huge pressures, okay, of the earth pushing down on top of those tunnels. Okay, so it is a dangerous game, and but in pursuit of gold, that's the chances that the gold mine operators are prepared to take. Okay, I think, Annie, that's sort of as a little intro into the process of gold mining.
That's great.
Good
I think
thing.
what we're going to do is we're going to take a little break. There are a whole bunch of questions coming on the page, which is fantastic. That's exactly what we want this lesson to be about. It's all about questions and answers, and those are your questions and answers. So while we take a break, get those fingers typing, post onto our page, facebook.com/learnextra, and you can even chat to me on Twitter @learnextra. Let's get chatting. See you now after the break.